Following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to look at section 8.5, which is solving absolute value equations. I want to start out by reviewing some basic things about absolute value. Absolute value is a distance. It's the distance between a number on a number line and zero. So for instance, let's say we have a number line here and we have the following, okay? The distance from 7 to 0 would be 7 units. Oops. The distance from -7 to 0 would also be 7 units because distance isn't negative. Now, the notation for absolute value is 2 vertical bars. So for instance, the absolute value of 7 is 7. But the absolute value of -7 is also 7 because -7 is 7 units away from 0. Any questions about that? Also, the absolute value of 0 is 0. Now, absolute value is never negative because, again, a distance is never negative. So it's either going to be a positive value or in the case of the absolute value of 0, it would be 0. All right, now, since the absolute value of -7 equals 7, and the absolute value of 7 equals 7, what if we had the following equation, and it said the absolute value of x equals 7? Well, then, looking at the information on the left side, we could say that either x would equal -7 or x would equal +7. In the case where x equals -7, the absolute value would be 7. In the case where x equals +7, the absolute value is also 7. So again, what we get is the absolute value of x equals 7 would be either x equals 7. Let's do it this way. Let's deal with a positive first. X equals 7 or x equals the opposite of 7. And again, it didn't really matter which answer I listed first, but I have my reasons for doing it this way. Okay, so now let's say we've got the absolute value of x minus 3 equals 12. Well, that means that x minus 3 equals 12 or x minus 3 equals -12. Because again, if this was 12, the absolute value of 12 is 12. If this was -12, the absolute value of -12 is 12. Now, going down and solving each of these two equations, if x minus 3 equals 12, we would add 3 to both sides and we would get x equals 15. If x minus 3 equals -12, we would add 3 to both sides and get x equals -9. Let's check both those answers. If x is 15, we'd have this. 15 minus 3 is 12. The absolute value of 12 is 12, so 12 equals 12. The first solution checks. If x equals -9, we'd get the absolute value of -9 minus 3 equals 12. -9 minus 3 is -12, and the absolute value of -12 is 12. So again, we get 12 equals 12. So both solutions are correct. Any questions about this example? All right. Suppose we've got the absolute value of 2x minus 4 equals 16. Well, then either 2x minus 4 equals 16 or 2x minus 4 equals the opposite of 16. Because if this equals 16, the absolute value of 16 is 16. If this equals negative 16, the absolute value of negative 16 equals 16. Are you seeing a pattern there? So what's inside either equals what the absolute value inside either equals the number on the right side or the opposite of the number on the right side of the absolute value, or of the equal sign, excuse me. Okay, so let's solve this first equation. We add 4, 2x equals 20. We divide by 2, x equals 10. To solve the second equation, we add 4, 2x equals negative 12, divide by 2, x equals negative 6. Let's check our work. If x is 10, we'd have the absolute value of 2 times 10 minus 4 equals 16. Well, 2 times 10 is 20. 20 minus 4 is 16. The absolute value of 16 is 16, so 16 equals 16, and it checks. If x is negative 6, we get the absolute value of 2 times negative 6 minus 4 equals 16. 2 times negative 6 is negative 12. Negative 12 minus 4 is negative 16. The absolute value of negative 16 is 16. So again, it checks. We get the two solutions. Again, any questions about this? All right. Let's say we've got this scenario. The absolute value of 3x minus 9 equals 0. Well, we've got 3x minus 9 equals 0, or 3x minus 9 equals the opposite of 0. But isn't the opposite of 0 just 0? I want to recopy this a little nicer. So we've got 3x. Yeah, isn't the opposite of 0 still equal to 0? So in the case where we have an absolute value equal to 0, we really only need the one equation, because both equations will ultimately be the same with the same solution. So here, I'm going to add 9 to both sides. 3x equals 9. Divide by 3, x equals 3. Checking our work. The absolute value of 3 times 3 minus 9 equals 0. 3 times 3 is 9. 9 minus 9 is 0. The absolute value of 0 is 0. 0 equals 0. So we get the one solution. Any questions? All right. Let's say we've got an absolute value equal to a negative number. Now, recall that I said an absolute value can be positive or 0, but it can't be negative. So already it looks like we're in trouble. Let's proceed and see what we get. X minus 7 equals negative 4, or x minus 7 equals the opposite of negative 4. If x minus 7 equals negative 4, adding 7 to both sides, we get x equals 3. If x minus 7 equals the opposite of negative 4, that becomes x minus 7 equals, well, the opposite of negative 4 is positive 4. Adding 7 to both sides, we get x equals 11. Well, let's check our work. If x is 3, we would get the absolute value of 3 minus 7 equals negative 4. 3 minus 7 is negative 4. The absolute value of negative 4 is 4. 4 doesn't equal negative 4. So that solution doesn't work. Let's check x equals 11. The absolute value of 11 minus 7 equals negative 4. 11 minus 7 is 4. The absolute value of 4 is 4. 4 doesn't equal negative 4. So that one doesn't work either. So there's no solution. Now, these solutions that we found are called extraneous. And sometimes WebAssign asks you to find them anyway and then determine whether they work or not. In this case, they don't work. But if you've got an absolute value equal to a negative number, I can tell you up front, they're not going to work. But you could still go through and find them following the process. But then when you check them, they won't check. Okay, now let's say we've got a situation like this. We've got the absolute value of x minus 10 plus 30 equals 50. I haven't had to mention this until now, but we want to isolate the absolute value term before we split it up into two possible equations. So in this case, the first thing we'd want to do is subtract 30 from both sides of the equation. Then we would get the absolute value of the quantity, x minus 10 equals 20. Now that we have the absolute value term by itself equals a number, we get x minus 10 equals 20, or x minus 10 equals the opposite of 20, or negative 20. So solving the first equation, adding 10 to both sides, we get x equals 30. Solving the second equation, adding 10 to both sides, we get x equals negative 10. Let's check our work. If x is 30, we would get the absolute value of 30 minus 10 plus 30 equals 50. Well, the absolute value of 30 minus 10 would be the absolute value of 20. The absolute value of 20 is 20, and 20 plus 30 is 50. So the first solution checks. The second equation, we get a solution, or the second solution, x equals negative 10. So we get negative 10 minus 10, absolute value of that, plus 30 equals 50. Well, negative 10 minus 10 is negative 20, and the absolute value of negative 20 is 20. And 20 plus 30 equals 50. So again, both solutions check. But the important thing was we first had to isolate the absolute value term before we split it up into two possible equations. All right, let's say we've got this scenario. Negative 10 times the absolute value of 16x plus 4 minus 3 equals negative 3. Now, you might look at this equation and say, oh, it's equal to a negative number on the right, so there's not going to be any solution. We can't be so sure. If we have an isolated absolute value term all by itself set equal to a negative number, that's when the solutions don't work. But we've got to isolate that absolute value term before we make any judgment calls. So the first thing I'm going to do here is add 3 to both sides of the equation. Then I get negative 10 times the absolute value of 16x plus 4 equals 0. Oh, see, it's not negative, it's 0. So that means we'll only have one equation. But wait, we're not done yet. We still haven't isolated the absolute value term. Let's divide both sides by negative 10. On the left side, I get the absolute value of 16x plus 4, and on the right side, 0 divided by negative 10 is 0. So now we're ready to go. We've got an absolute value term equal to 0, so we're only going to have one unique equation, which is going to be 16x plus 4 equals 0, because if we said 16x plus 4 equals the opposite of 0, we'd get the same ultimate equation with the same solution. So now, solving this equation, subtract 4, 16x equals negative 4, divide by 16, x equals negative 1/4. Let's check our work. We'd have negative 10 times the absolute value of 16 times negative 1/4 plus 4 minus 3 equals negative 3. Solving inside the grouping symbol first, or simplifying, 16 times negative 1/4 would reduce down to negative 4. Negative 4 plus 4 would reduce down to 0. The absolute value of 0 is 0, so I've got negative 10 times 0 minus 3 equals negative 3. Negative 3 equals negative 3. So we get the one solution, and it checks. Again, any questions about this particular example? Okay, let's take a look at another scenario. Let's say we've got 4x minus 7, that is the absolute value of 4x minus 7, equals the absolute value of 3x minus 21. Well, let's come back to that situation. First of all, I want to look at this. Would the absolute value of 7 equal the absolute value of 7? Yeah, because 7 equals 7. Would the absolute value of negative 7 equal the absolute value of negative 7? Yeah, because 7 equals 7. Well, how about the absolute value of 7 equals the absolute value of negative 7? That would still be 7 equals 7. And we could have the absolute value of negative 7 equals the absolute value of 7. We still get 7 equals 7. So those two, when we have two absolute value terms and nothing else, and there's one on each side of the equation, we've got these 4 different scenarios that all lead to the same answer. And that is that 7 equals 7. So they're all true. Let's take a look at this situation. So what's inside here could equal what's inside of there. That's one possible scenario. The opposite of what's inside here could equal the opposite of what's inside there. That's another scenario. Or we could have what's inside of the first one equals the opposite of what's inside of the second one. Or we could have the opposite of the first one equals what's inside of the second one. So I've got those same kind of 4 different scenarios. But let's take a closer look. If we took the first equation and we multiply both sides by -1, wouldn't we have the second equation? So in fact, those two cases are really the same case. So we don't need this second idea. Let's take a look at the third equation. If we took that and we multiplied both sides by -1, on the left side, we'd get this. On the right side, subtracting a negative would become adding a positive, and we'd get that. So the third and the fourth equations are actually identical. So we can get rid of that. So of those 4 scenarios, there's really only 2 unique scenarios. Let's go back to the actual problem again and look at what we're going to keep. Whoops, let's do this. We've got the absolute value of 4x minus 7 equals the absolute value of 3x minus 21. So we kept this one where we took what's inside equals what's inside. And then we kept this one where we took what's inside of one equals the opposite of what's inside of the other, which is basically what I've been doing all along. The only problem is I meant to write that one up here so that I would have room to solve them both. So let's move that up there. There we go. There we go, finally. Okay, so what's inside of one equals what's inside of the other, or what's inside of one equals the opposite of what's inside of the other. Solving the first equation, I'll subtract 3x from both sides. X minus 7 equals -21. Add 7 to both sides. X equals -14. Solving the second equation, 4x minus 7 equals, distributing -3x. Negative times negative is plus 21. Okay. I'm going to add 3x to both sides of the equation. 7x minus 7 equals 21. Add 7 to both sides. 7x equals 28. Divide by 7 and x equals 4. So I've got 2 possible solutions. Let's check our work. If x is -14, we'd have the absolute value of 4 times -14 minus 7 equals the absolute value of 3 times -14 minus 21. 4 times -14 would be -56. Negative 56 minus 7 would be negative 63. And the absolute value of negative 63 is positive 63. So far, so good. Okay. 3 times negative 14 would be negative 42. Negative 42 minus 21 would be negative 63. And the absolute value of negative 63 is 63. So the first solution checks. All right. I'm going to erase some of the writing here so that I have room to check my second equation without having to go to another screen. So if x is 4, we get the absolute value of 4 times 4 minus 7 equals the absolute value of 3 times 4 minus 21. On the left side of the equation, 4 times 4 is 16. 16 minus 7 is 9. The absolute value of 9 is 9. On the right side of the equation, 3 times 4 is 12. 12 minus 21 is negative 9. The absolute value of negative 9 is 9. And again, both solutions check, but you always want to check your answers to make sure they're going to work. Any questions about this example? Okay, let's see here. Let's take a look at this one. The absolute value of 2x plus 1 equals the absolute value of 3 times the quantity x plus 1. What we're going to do first of all is we're going to simplify inside the grouping symbol. The left side, nothing's going to change. Whoops. Well, that's supposed to be absolute value. On the right side, distributing, we're going to get 3x plus 3. Okay, so we'll simplify inside first. So now one of my possible equations is going to be 2x plus 1 equals 3x plus 3. And the other one, 2x plus 1 equals the opposite of 3x plus 3. So now it's really just like the last scenario. But I wanted to simplify inside the absolute value bars before I worked on getting rid of them. All right, the first equation, the one on the left that is, we'll subtract 3x from both sides and get negative x plus 1 equals 3. Subtract 1 from both sides, negative x equals 2. Divide by negative 1, x equals negative 2. The second equation, we've got 2x plus 1 equals negative 3x minus 3. Distributing the negative sign. We'll add 3x to both sides of the equation. 5x plus 1 equals negative 3. Subtract 1 from both sides. 5x equals negative 4. Divide by 5, x equals negative 4/5. So we come up with 2 possible solutions. Any questions before we check the work? All right, so I think I'm going to recopy this on the next page rather than erase everything. Let's see, where did it go here? All right, so the absolute value of 2x plus 1 equals the absolute value of 3 times the quantity x plus 1. And we have x is negative 2 and x is negative 4/5. Negative 2, negative 4/5. All right, so let's take the case of x equals negative 2. We would get the absolute value of 2 times negative 2 plus 1 equals the absolute value of 3 times the quantity negative 2 plus 1. On the left side, 2 times negative 2 is negative 4. So we have negative 4 plus 1, which is negative 3, still inside the absolute value bars, but the absolute value of negative 3 is 3. On the right side, inside negative 2 plus 1 would be negative 1. 3 times -1 is -3. The absolute value of -3 is 3. So this solution checks. Okay, let's take the -4/5 scenario. We have the absolute value of 2 times -4/5 plus 1 equals the absolute value of 3 times -4/5 plus 1. Okay. So on the left side, let's see. 2 times -4/5 would be -8/5 plus 1. I need a common denominator, which would be a 5. So I'm going to want to get that. So I'm going to take the 1 and multiply it by 5/5. So a -8/5 plus 1 becomes -8/5 plus 5/5, which would be -3/5. And the absolute value of -3/5 would be 3/5. Any questions there? On the right side, let's see, we've got the absolute value of 3 times -4/5 plus 1 would be -4/5 plus how many fifths? Well, I'd take 1 and multiply it by 5/5. So I get -4/5 plus 5/5 inside the parentheses, which becomes what? 1/5. And 3 times 1/5 would be 3/5. And the absolute value of 3/5 is 3/5. So that took a while to get there, but both solutions check. Again, any questions there? All right. I had a student request this particular problem. So let's take a look at this. Here's the equation. It says 11/18 equals the absolute value of x over 6 minus 8x over 9. Now, you don't have to do this, but I just like to have my absolute value on the left. So I'm going to rewrite this whole thing. In fact, I'm just going to do this. Okay, so it's the same equation. I just put my absolute value on the left. All right, so now let's see. I've got, what have I got here? Let's see, x over 6 minus 8x over 9 equals 11/18, or x over 6 minus 8x over 9 equals the opposite of 11/18. Okay, now both these equations have fractions, and I can clear the fractions by multiplying both sides of the equation by the least common denominator. And the least common denominator of 6, 9, and 18 is 18. So I'm going to multiply this by 18 and that by 18. On the left side, I get 18 times x over 6 minus 18 times 8x over 9 equals 18 times 11/18. 18 over 6 is 3 over 1, so I get 3x minus. 18 over 9 is 2 over 1. 2 times 8x is 16x, and 18 times 11/18 is 11. Going on, 3x minus 16x is -13x equals 11. Divide by -13, and we get x equals -11/13. Okay, so there's one potential solution. Again, before I go on, any questions there? Okay, the second situation, again, the LCD is 18. So again, we'll multiply both sides by 18 and distribute. So we get 18 times x over 6 minus 18 times 8x over 9 equals 18 times -11/18. 18 times x over 6 reduces to 3x over 1, or 3x, minus 18 over 9 is 2 over 1. 2 times 8x is 16x, equals 18 times negative 11/18 is negative 11. Simplifying further, negative 13x equals negative 11. Divide by negative 13x equals 11/13. So I've got two possible solutions. Well, I said we better check our work, so here we go. So I'm going to recopy that original equation. Let's see if I can find it here. Oh, here it is. Okay, I'm going to write it with the absolute value on the left. So I've got the absolute value of x over 6 minus 8x over 9 equals 11/18. And our two answers are x equals negative 11/13 and x equals positive 11/13. So here we go. This is going to get worse. Okay, so if x is negative 11/13, we have this. Negative 11/13 over 6 minus 8 times negative 11/13 over 9. Absolute value equals 11/18. Okay, now let's take this individual piece right there and deal with it. Negative 11/13 divided by 6 is negative 11/13 divided by 6 is negative 11/13 times the reciprocal 1 over 6, which would be negative 11/18. So now I've got this, okay, minus, and let's see here. Here we're going to multiply that together first. So that's going to give us what? Negative 88/13. 8 times negative 11. I told you it was going to get worse. Negative 88 over 13 divided by 9 is negative 88 over 13 divided by 9 is negative 88 over 13 times 1/9, which would be negative 88 over, let's see, 90 and 27 would be 117. Wow. Okay. And that all equals 11/18. Well, let's see. Negative 11/18 minus negative 88 117. Subtracting a negative would be like adding a positive, okay? But we need a common denominator. So we need a common denominator between 18 and 117. Wow, let's see. 18 is 2 times 3 times 3. 117 is, let's see, 3 times 3 times 3 times 3 times 3. Is that right? 3, 9, 27, 81. No, that's not right. Too many threes there. Hang on. Let's see here. 117 divided by 9 is 13. Is that right? 9, 20. Yeah, 13. Okay. So this is 3 times 3 times 13. Wow, this problem just keeps getting worse, doesn't it? So my LCD is 2 times 3 squared times 13, which is what, 18 times 13? What's 18 times 13? Let's see. 18 times 13 is, oops, hang on. 18 times 13. 18 times 13. Well, this is interesting. I bought this calculator over the weekend at a discount store, and it's giving me a wrong answer. Let's try this. Okay, 18 times 13. No. Yes, 18 times 13. 234. Wow. So negative 11/18, I've got to multiply by 13 over 13. Okay, 13 over 13. So in the numerator, negative 11 times 13 becomes negative 143 over 234. And 117, I've got to multiply by 2. So 2 over 2, which would be what, 176? Remember, we're still checking just the first answer. Whoa. Okay, now, what's negative 143 plus 176? That's 33. So we've got, I'm going to go to the next page, 33 over 234 equals 11/18. I think I've done something wrong here. Let's see. Yeah, I think somewhere along the line I've made a mistake, because if I divide the top by, let's see, if I divide the top by 3, let's see. I take 33 over 234 and I divide by 3, the top and the bottom, they don't equal. So I made a mistake here. Ugh. All right, let's see if I can find it. I can tell you that the answers are correct. I already know that. So somewhere along the line, I must have made a mistake plugging that in. So let's see if we can find it. Okay, so here's my original equation. Let's make sure that I've copied that correctly. I know it's turned around, but that's not going to affect the answer. Where is that? Oh, it's right here. 9. Okay. Now, if x is negative 11/13, that would go in there and there. So negative 11/13 divided by 6, negative 11/13 divided by 6, negative 11/13 times 1/6 would be, oh my, right there. There was my mistake right off the bat. Is anyone there paying attention? You should have yelled at me. This shouldn't be 18. It should be what? Anybody?
19?
Actually, it'd be 78.
Oh.
6, see that? 13 times 6, 78, and I wrote 18. Okay. I'm going to go back and check my work again, drag you through this nasty problem. My apologies. Here we go. That's what I get for being in a hurry. All right, so let's take x equals negative 11/13 and plug it in. Okay, so this is going to be negative 11/13 over 6 minus 8 times negative 11/13 over 9 equals 11/18. I'm going to take that, negative 11/13 divided by 6 is negative 11/13 divided by 6 is negative 11/13 times 1/6, which is negative 11 over 78. That changes everything. So this becomes negative 11 over 78, okay, minus. Now let's deal with this. That's going to be negative 88/13, then divided by 9, which is negative 88/13 divided by 9, which is negative 88/13 times 1/9, which is negative 88 over 117, 90 plus 27. Okay. Wow. This is still looking pretty ugly. Subtracting a negative is like adding a positive. Well, let's see. 78 and 117. What's the least common denominator there? 78 is let's see, where did we get that? We got that from 13 times 6. That's 2 times 3 times 13. And 117 is 3 times 3 times 13. Oh, that's not going to be so bad. So it's going to be 2 times 3 squared times 13. That's going to be our LCD. Any question how I got that? Okay. So 2 times 3 times, that's 18 times 13. Let's see here. I think that's the same thing we had before. 234. Yeah. So this is going to be that. But to get from 78 to 234, I have to multiply by 3 over 3. So this is negative 33. To get from 117 to 234, I have to multiply by 2 over 2. 2 times 88 is 160, 176. Okay. 176 minus 33 is 143 over 234. Well, let's see if that works. If I take 143 over 234, 143 divided by 13, and then 234 divided by 13, and we get 11/18 equals 11/18. So after all that, the first one checks. So I guess the word to the wise that I need to keep telling myself is slow down. I always look at the clock and panic and go, oh, I got to hurry. And I made a mistake early on in checking my work that took me wasted 10 minutes of your valuable time. My apologies. Okay. Now, to go back and check the other one, do you want me to do that or do you care? No one cares. Well,
You can do the other one.
what's that?
Can you do the other one?
I can, which would be what, 11/13, right? Positive 11/13. So here we go. X over 6 minus 8x over 9 equals 11/18. X equals 11/13. So we're going to get 11/13 over 6 minus 8 times 11/13 over 9 equals 11/18. A lot of it's going to look the same or very similar. So let's see. Let's take that. 11/13 divided by 6 equals 11/13 times 1/6 equals 11/78. So this is 11 over 78. And then let's deal with that. Minus, let's see, 8 times 11/13 is 88/13. 88/13 divided by 9 is 88/13 times 1/9 is 88 over 117. Okay, now we've got the same denominators we had before. So the least common denominator is still going to be 234. Okay, I don't need to go back and find that again. I'm going to have to multiply, let's see, 234 divided by 78 is 3. So I'm going to multiply by 3 over 3, which gives me 33 2/34. And I'm going to multiply by 2 over 2, which gives me minus 176 2/34. 33 minus 176, I get negative 143 over 234. the absolute value of which is 143 over 234. And we end up with the same, let's see, where did we have that? We had 143 over 234, the last one. So that reduces down to 11/18 equals 11/18. So the process of doing this one is the same as before, but you just got to be really careful that you do all the little pieces correctly, which I, again, messed up that very first multiplication. Okay, so in review, when you have an equation containing one absolute value term, isolate it first. If you have that equal to a positive number, you're going to have two potential equations with two potential solutions. If you have it equal to 0, you're going to have one equation with one potential solution. If you have it equal to a negative number, if you solve it, you're going to come up with solutions, but when you check them, they're not going to work. Okay. If you have an equation with two absolute value terms, put one on each side of the equation and go from there. Then the question is, what if you have an equation with two absolute value terms and yet another term? We're not going to go there, so you don't need to worry about it. Okay. Do you have any questions?
No.
Nope.
All righty. Well, I'll be back at 1:15. Good luck. Be careful and go slow.
Thank you.
Uh-huh.